Hello. So right now I will talk about chapter 3. I want to go through all of the things in chapter 3 in 20 minutes. So right now is 5:20 p.m. and I will end this lesson at 5:40. So there are a lot of things to do. Let's start. The first thing I want to check is list. So I will share my screen with you and we can code together. Okay. So we will look at list, right? And okay. So for a list, the most important thing is that actually list it can be modified. So you can actually change, for example, a tuple into a list with this. Change it with this. We know here is tuple. Here are tuple values that we have run before. Okay, tuple. See, now the tuple is changed to a list. The next thing we want to check is that lists and tuples are similar and can be used interchangeably in many functions. So, for example, for this range thing is 10, right? And we get this range. And so, what is the type of this variable? Okay, it's a range. And then we just use this to wrap it, and we will get a list. That's next thing we will look at is adding and removing elements. So adding and removing elements. Adding and removing elements of Python, right? So how to adding actually, which is very easy, which is to okay, this one is a and then a dot append. Actually, you can even append a string here. See, the other elements are integer and only one, this new one is a string. And we want to remove, another thing is that, okay, let's continue to look at add. So we can also use insert, which is insert a dot insert. Then here is the index. Okay, for the second one, and I want to insert happy. What will be the result? See, right now the second element is changed to happy, and any other things actually move to the next location. So insert is expensive, computationally expensive compared with append, because references to subsequent elements have to be shaped internally to make room for the new element. So we may not use insert a lot, right? The inverse operation to insert is pop, which removes and returns an element at a particular index. A dot pop. Right now I want to remove the second element. A dot pop. 1, and right now let's check A. Okay, the happy is removed successfully, right? And elements can be removed by value with remove, which locates the first such value and removes it from the list. So how to understand this is that if there are duplicate values in a list and remove, we'll just remove the first such value. For example, we have this list. Well, there are 1, 2, 2, 3, 2. Right. Right now we remove 2. And let's check what's in L. The first one is removed. First 2 is removed. Okay. So the next thing is about if performance is not a concern, by using append and remove, you can use a Python list as perfect suitable multi-site data structure, which is so check if a list contains a value we will use in. We can check, for example, 1 in L. It is true, and 4 in L. No. The next thing about list is to add list together and also to combine the lists. So for example, we add A and L. What happened? You can see these two is actually like you append one list to another list, right? And also we can do the extend, which is A dot extend L. Okay, let's first see that A is, this is A, right? And what's A looks like before we add them together. Then we add them together and then we check if A is changed. No, A is not changed. But if we use extend to add to like merge two lists together, right now A is changed. So that's the difference. So note list concatenation by addition is comparatively expensive operation since a new list must be created and the objects copied over. Use extend to append elements to an existing list, especially if you are building up a large list. It's usually better. So remember to use extend, okay? And let's go to the next part, which is sorting. So when you want to sort a list, what you can use is sort, okay? Because we have string and integer together in this list. So I will, okay, let me, remember we can remove some element, right? We want. So we remove string and what do we get? Okay, right now let's do the sort. See, right now we get a ordered list. So sort has a few options that will come in handy. One is the ability to pass a secondary sort key, a function that produces a value to use to sort the objects. For example, we could sort a collection of strings by their lengths. So, what should we do is I need to create a new list with the strings because for every number in this in A list, the length is the same. So how can I sort them by length? So I create another list with all strings, which is happy. Here, free, free, free. Right now, I want to sort them by the key. So by length. So what should I do is okay, len key equal to len. Actually, we don't need this here. So d, let's see what is d. See, right now everything is sorted by the length. Okay, soon we will look at the sorted function, which can produce a sorted copy of a general sequence. And then we will go to the next part, which is a binary search and maintaining a sorted list. So the built-in Bisect module implements binary search and insertion into a sorted list. So this bisect method finds location where an element should be inserted to keep it sorted, while bisect insert actually inserts an element into that location. Okay, this is a new thing that I have never met before, so let's check it carefully. So first I will import bisect, and we have a list, which I will still use right? And then what I want to do is bisect p dot 2. So what's the meaning of that? It is finds the location where an element should be inserted to keep it sorted. So right, if I want it to be sorted, I mean the list to be sorted, then I want to insert 2. So where should I put it? I should put it 0, 1, 2, 3, 4, 5, 6, right? I should put it there. Okay, that's very interesting. And then insert is to insert the element into that location. So what we will do is so this one is to tell you the location where to insert, and insert is to just put that number there, a dot 2. Let's see what happened to a. Okay, right now we put these 2 things in the 6th index place or location. The next thing about list is slicing. So for slicing, we can select sections of most sequence types by using slice notation, which is basic from consists of start to stop passed to the indexing operator. So for A, we will use this bracket, this hard bracket, and there is a start point and end point. Start point, end point is the index, okay? So yeah, that's what we get. The 1, 1, 2, 3, 4. It only includes a start index, but without a stop index. So the number of elements in the result is stop minus start. And either the start or stop can be omitted, in which case they default to the start of the sequence and the end of the sequence. So like this, A. Yeah, only the first 4 of them. And then this one is after this, right? After the 5th index. Okay, let's see. So negatively in the negatively indices slice a sequence relative to the end. And slicing semantics takes a bit of getting used to. I don't think that's important, or that is not a difficult thing for me. So let me stop here.